Okay, we're finally to the book of IM2. So we're going to be proving geometric relations, and here are some of the things you're going to be doing, but let's get going. So remember, a proof is a logical argument that uses deductive reasoning to show that a statement is true. So this is just a great introduction to what you're trying to do in a proof. You're solving a puzzle, you're reaching a goal, but you must use logic. So you have to justify every statement and make sure that the statements and justifications link together to form the proof. So here we go. A two-column proof has numbered statements and corresponding reasons that show an argument in logical order. This is in your journal in page 187 if you want to take notes. So we're given that AD, that's AD, is equal to AB plus AC. So this isn't as easy as it looks. And we need to prove that CB, so we're going to draw this quickly over here so we can see it. A, B, C, D. We want to prove that AB equals CD. We're going to prove that. Okay? So first thing they did was wrote down the given. The next thing they did was they said AC plus CD equals AD. So we look at our picture, AC plus CD equals AD. Oh, that's the segment addition postulate. We forgot to put those up. That's the segment addition postulate. There you go. Now we're going to put AC plus CD equals AB plus AC. How did they get there? So go back here and notice that this is equal to AD and this is equal to AD. So by the transitive property, they are equal to each other. And notice these are equal signs, so you want to say of equality. And now that we've done that, we can look here and say there's CD, there's AB. Oh look, we can subtract AC, subtraction property of equality, to get our final prove statement. Okay, so this just gives you an explanation of what a statement is and what the reason or justification is for that statement. Okay, here's another fill in the blank. So this one has blanks on the statement side. So let's see how you do. So we have the measure of ABD, that's this one, is equal to the measure of CBE. That's this one. So those are equal. They want you to prove that angle 1 is equal to angle 3. So first thing they do is they give you the measure of angle ABD. So they're not giving you the given first. That is not required. So the measure of angle ABD equals the measure of 1 plus 2. That's the angle addition postulate. Now, they don't show me this one, but they do show me that the angle addition postulate is used again. So I look at angle CBE and I say, oh, that's the measure of angle 2 plus the measure of angle 3. Then they tell me my given, so I'm just going to go ahead and write my given right there. Then they set this equal to each other by the substitution property. Notice they said, they substituted this for ABD, so right there, they substituted there, and then they substituted this for CBE, right there. This was not a transitive property because we didn't have three things. We were substituting one thing for another, so be careful with that. We haven't really talked about substitution property, but that's how it works. And then the last one is, I need to get to measure of angle 1 equals the measure of angle 3. So I see that I have the measure of angle 2 here, so I'm going to subtract that out, and I get the measure of angle 1 equals, that should be equals the measure of angle 3. And that's the subtraction property of equality. All right. Okay, so one of the IM2 standards is that you have to be able to write a proof for an existing theorem. So this is an example of one of those. You can pause and look through it. The number one thing that you have to remember is that when you're trying to prove a theorem, you can't use the theorem as a justification in your proof. It can't be there. So you have to find another way to prove things. So look through this one and see how they did that. A paragraph proof, we've already talked about these once, presents the statements and reasons of a proof as sentences in a paragraph. So here's an example, but what I really wanted to show you is how you take a paragraph proof and make it into a 2-column proof, or even how you could go backwards to a paragraph proof. So if writing the 2-column proof is easier, then you would use transitive words to make it into a paragraph proof. So you can pause and look at this one too and review how they put it together. But notice it's in the same order, it just has different wording. Okay, so this is a paragraph proof, fill in the blank. So we're proving that angle 1 is congruent to angle 2. We are given that these are parallel. So first thing is angle 1 is congruent to angle 3 by corresponding angle theorem. Okay, and angle 2 is congruent to angle 3, sorry I said them backwards, by the vertical angle congruence theorem. So therefore angle 1 is congruent to angle 2 by the transitive property of congruence. So it's a pretty basic paragraph proof, not too hard. Okay, a flowchart proof, we've already gone over this, uses boxes and arrows to show the flow of a logical argument. So this one gives you a really good way of doing this one. So if you want to pause and look at this, what they're using here, and you might get confused, is they use the alternate interior angle theorem. Well, the first thing they did was they drew, and this is part of some proofs, is they drew BD. Remember that postulate that said there is, through any point that is not on a line, there is exactly one line that goes through it that is parallel. So they created a parallel line through BD, and we learned how to do that when we used a compass. Unfortunately, you guys didn't get to learn to use compasses last year to learn to do that, but we can learn that in the future. And so that would make these, if you look carefully, these become alternate interior angles because we think of AB as a transversal. So that's how they set it up. And then also angle 5 and angle 3 are alternate interior angles because this one also becomes a transversal. So this is a really neat proof that teaches you to think outside the box. So stop and take a look at it. It's a really good one. Okay, this is showing you how to take that flowchart proof and put it into a 2-column proof, or vice versa. Okay, so it teaches you how to transition from each step. Notice that it goes one direction, and it also goes in another direction, and then it winds up at the same place. So review this one as well, push pause, just give it a look-see, and see how it moves. Okay, so we're going to complete the flowchart proof of the base angles theorem. This is a theorem of an isosceles triangle, so it's important that you'll learn these along the way. And the base angle theorem is that the base angles of an isosceles triangle are congruent. So what we have to prove is that angle B is congruent to angle C. That is what we're trying to prove. Okay, we're trying to prove the base angle theorem. So the first thing we're going to do is we're going to construct a bisector of angle CAB. That's this angle here. We're going to bisect it. We also learned to do that with a compass. So we bisect it. That means that these two angles are equal. Okay, and that is what we're going to put here. So we created the bisector, and now we can say that angle CAD is, the measure of CAD is equal to the measure of BAD. Okay, we can also say, now that we've created this bisector, that DA is congruent to DA. That's the reflexive property. That's this line is equal to itself. Then we have our other given, which our diagram showed us, was that AB is equal to AC. If it's on the diagram, it is a given. And now put all those things together, and we've proved that angle ADB is congruent to ADC. Make very sure that you're putting things in the same order. I started with A, I went to D, and then B. So I went like this. So that means I have to go ADC, because these two sides are the corresponding sides in the triangle, so they have to be in the same place. Okay? All right, and the two angle A's are in the same place. Okay, so that's really important when you're drawing this kind of a conclusion. And what did I use? Well, I have side, angle, side. So I would use the side angle side congruence theorem. And now that I've got the side angle side congruence theorem, I can say that angle B is congruent to angle C because of CPCTC. And that is the corresponding parts of congruent triangles are congruent. And B and C are now congruent parts because here they are in the same position. There you go. Okay, there's one more kind of proof that they haven't shown you. A coordinate proof involves placing geometric figures in a coordinate plane. When you use variables to represent the coordinates of a figure in a coordinate proof, the results are true for all the figures of that type. So this is showing you that you're going to write a coordinate plane. The points are your given, okay, and you need to prove that angle PQR is an isosceles. They don't tell you which two sides are going to be congruent, so you have to figure that out. And they did that by using the distance formula. The thing you need to remember is that when you square negative h, that equals h squared, if that confuses you. And knowing that an isosceles does not have a third side that's equal, we know that the distance here is h, and the distance here is h, so this base is 2h. So we proved that it's an isosceles. So maybe you want to pause and think that one through, work out with the distance formula. Good luck. Okay, here is your exit ticket for this unit, and you're going to be answering, filling in the blanks on each of these 10 different segments. So good luck with that. These are in your book, so you can practice in your journal on page 190 and 191. That's it.